Okay, so for today, we'll make the LED blink and the speaker beep. And let's check the connections. So I have connected the power rail to the microcontroller. So the red wire connects to 5 volts. So 5 volts is over there. And which means that this entire line or row will be 5 volts. And I have connected the other row, the bottom row, to 5 ground. So this entire row here will be ground. And here we have the LED. The ground or the negative leg connects to the resistor, and the resistor connects to the ground. Now we have to add a resistor either on the positive leg or on the negative leg to allow the red LED to work with 5 volts. And we have no connection yet for the speaker. So let's start with the speaker. So the negative leg is actually also here. And I'll connect it to ground. And then I'll connect the positive leg or positive terminal to pin number 3. We will follow the connection or wiring based on the robot, and then I'll connect this also to pin number A1 or pin number 15. Let's check this out first. So I'll plug this in, and then let's check what will happen if I connect the LED to 5 volts. Okay, so if I leave it connected there, it will stay that way. But what we're going to do later is we're going to make our code stored in the microcontroller control when the LED should light up. So I'm going to connect this to pin A1. Okay. Pin A1 is over there. So we're working with light that you see here, so I'm very careful. And then same thing with the speaker. The speaker can handle up to 5 volts. So if I leave it there, it will stay that way. But instead, we're going to connect it to another pin, and we'll connect it to pin 3, or digital pin number 3. There. And then let's work on the program. So here, let's check the connection first. Tools. So you have Arduino Nano, and then the port is 6. Make sure you are connected to that port, and it may be a different port depending on what is stated there. So you have to select the correct port. We have several ports appearing there. The newest one will be most likely the correct port. And then for the processor, is either you use the old loader or the plain 80 mega E to 8P. So whichever works, that's it. Okay, so let's start with the program definition. Just a simple definition what your program is for. In this case, let's say written by you. Just a demo on the use of LED and speaker. Simple as that. And then I'll have to declare some variables. I'll declare a variable that will hold the pin numbers of the components. I'll start with LED. Constant in LED. So LED is a variable, and it will contain 15 because A1, where the pin is connected to, or where the LED is connected to, is also known as A1. A1 is an analog, but it can be a digital pin. And in this case, we connected it to the LED. And for the speaker, I'll have to say pin 3. Okay, but please take note, the pin 3 is a PWM pin. Oops. Okay. Then for the setup, so this is the main code. Will set up the mode of the two pins. So pin mode for LED. So it means basically 15 because that's what we stored in that variable. So the pin mode for LED is output. Just going to be sending signals out. And in this case, signals are basically electricity, and we'll be sending 5 volts out. Pin mode for the speaker is also output. Oops. Okay. And then, so in loop, we'll say I want the LED to light up. So I'm going to send a signal, digital right LED. What kind of signal? It will be high or low. Low means 0 or nothing, and high for 5 volts, full 5 volts. Because this is a 5 volt system, it's either 5 or 0. So I say high. So I'll be sending a signal out, and then I want to wait for 1 second. So that's 1000 milliseconds before I switch it off. So basically, we are going to send a signal out, but this time it's a low signal, which is equivalent to 0. And then I'm going to set a delay to 1000 milliseconds, which is 1 second, before the loop happens again. So these are the things that will happen in the loop. So this will be done, these 4 lines will be done over and over again. So let me just upload. So I'll click upload. This will compile and upload at the same time. So let's check. It's not uploading, so let me just change the settings. I'll do it again. And I'll try again. Oops. Wait, it uploaded. Okay. Sometimes that happens. Okay. So, as you can see, based on the code, it will send a high signal, which is 5 volts, and then wait for 1 second, and then switch it off by sending a low signal, and then wait for another 1 second, and then everything happens over and over again. Okay, so let's do the same for the speaker. So for this one, let's separate the two. Instead of LED, I'll use speaker. Make this short. Let's say 50 milliseconds, and then before I switch it off. Then maybe another or maybe 1 second delay before everything happens again. So it will be a short beat, and then so I'll be sending the full 5 volts before I switch it off. Then let's check the output. There. So if we are going to make the LED blink too, we'll just do the same. There you go. Okay, so let me just make the speaker, comment on the speaker so that the speaker will be disabled. So I'll upload the same program or sketch, as you call it in Arduino. Okay, so the speaker is not receiving any signal now. No. Okay, so which means that you can just switch it on, off, anytime you like. However, in this case, for me to be able to blink or beat the speaker, it takes around 3 to 4 lines. Okay, so there's a better way of doing it. So let me just show you by making a function, a set of code that is meant for a specific task. In this case, for the LED to switch on or off. Let's start with that. So I'll make the function void, meaning it's not going to return any value. It will just do a set of tasks. I will name the first function as LED on. Its task is to switch on the LED. And another function, I'll just copy it and paste it below, and I will name it as LED off, which obviously will switch off the LED by sending a low signal. And instead of writing a statement this long, I'll just write LED on, which is a lot shorter than digital write. Let's check my uploading. Are we going to get the same result? Let's check. High, low. Wait, I forgot to add those. Okay, so let's do it again. Excuse me. There you go. All right. And then what we'll do is we'll make it even better. So let's say I want to, instead of writing all of those, I would like to make the LED blink in one go. So I'll say blink. But I have to specify the duration between on and off. So here I have to add a variable that will take care of that detail. So that is in milliseconds. Maybe an integer will do, or a long integer. Blink long for a long integer, and then let's say duration. All right, so that will be in milliseconds, and okay, so I'll change it to int because blinking will not take that much. Take that long. So an integer will do, and then I'll say LED on, and then LED off, followed by okay, in between would be delay. How much of a delay will depend on whatever is stored in duration. Okay, so let's test. I'll erase all of these except for the delay at the end. I'll just erase this also. And I'll say blink, uh, let's say 100 milliseconds. So switch it on. Okay, so 100 goes here, duration. Switch it on, wait for 100 milliseconds, and switch it off. And then delay for 1 second and do everything again. Let's upload. Let's check. There, it works. So I just made use of one line of code. And the details on how everything happens is actually over here. I have moved all the details of the code from the main code to the or as user-defined functions below. So this makes our main code a lot easier to read and easier to manage. And we have now created a function that we can use anytime or anywhere in the program or in your sketch. And let's do the same for the speaker. So here, I'll use the same function, but I'll change the name to beep, and then I'll specify the duration. And probably it would be also nice if we can create a function for the speaker. Let's say, I'll probably just copy this. And change this to speaker. Speaker on, speaker off. And then change this to speaker. And here, this is speaker on. And speaker off. Okay, so instead of blink, I'll use beep. Let's say make it short. 50. There, and then there. So I can make the speaker beep in one go. But of course, this time I won't be able to make the LED blink and the speaker beep at the same time. I have to write another code for that. But in this case, as you have seen, I have specific functions for specific tasks, making my code a lot easier, organized, and it allows me to focus on the main task. Okay, there you go. Oh, one more thing. Remember, wait, let me just remove the beep. Remember that the speaker is a PWM or is connected to a PWM pin, which means that I can actually send an analog signal via pin number 3. And to create an analog signal means a variation of the signal. So instead of 0 or 5, that would be any signal between 0 and 5 volts. And to do that, I'm going to use analog write. So for beep, so I'll make changes. I'll use 2 variables, int power and int duration. Power refers to the amount of power or analog signal that will be sent to the speaker. That will be from 0 to 255. 255 is 100% and 0 is 0%. So here, I won't be using speaker on. I'll be using analog, right? So speaker, and then power. The amount of power will be set to the speaker. And then I'll be using speaker off is okay. Speaker off will send a signal, a low signal, meaning it's 0. So I can use analog right and set the power to 0, but this is the same thing, so that's okay. And here for in the main code, so I'll use beep, but this time I can set the power. So let's say instead of full 100%, which is 255, I'll use 127, which is half of 255, 127 or 128, and then same 50 millisecond delay for the beep. So let's check. Okay, let's check different output. I'll make this lower. And this is 100%. Let's make it a little bit longer. Alright, so let me just switch it off. And try the code on the robot. Remember that the connection is the same with the robots, so it should work. So I'll connect this. Okay, make sure that there is no code or program uploaded to the robot, or the what is uploaded to the robot is an empty program, right? Sketch. So I'll make it beep and then make it blink first. Blink for 50 milliseconds, then beep. Okay, and then do everything over and over again. So let's upload. Uploading. I'll check. Okay, the connections are okay. However, I may have changed the processor to the output folder, and then I'll do the upload again, and it should work this time. Try again. There. There. So it works. It's the same thing, same connection, and take note to always make sure that you use functions to better organize your code. And that's it for now. Thank you.